Welcome back, everybody. In this video, we got three vectors, A, B, and C, and we're told the cross product between A and B is 3, -2, and 5, and the cross product between A and C is 9, 7, and -2. And we have to determine the cross product between 3B minus C, which is a vector on its own, and 2A. So the cross product between those two vectors. So this is a vector, and then this is a vector in brackets here. So this question is pretty tricky. What you have to do is you're going to have to apply a lot of cross product rules. So first thing you want to do is you want to sort of distribute this 2A inside the bracket and then take multiple cross products. So what I mean by that, if you remember cross product rules, let's say that we have a vector A plus B, and we're taking the cross product between this vector in brackets and another vector C. Well, that's the same as A times C plus B times C. So you're like distributing this times C inside the bracket. Well, same thing here, but we're going to distribute the 2A inside the bracket. So we can rewrite this as 3B times 2A, right? The cross product between 3B and 2A, minus C times the cross product between C and 2A. Now, you got to be careful with the order. The order actually matters. So notice that C is on the end here, and notice that C is on the end for these two, right? A and B come first. Same thing here. Notice that 2A is on the end, so 2A is going to be on the end of both of those cross products after you distribute. So you can't just write this as 2A times 3B. It's got to be 3B times 2A, and it's got to be C times 2A. And you'll see in a bit why that is important. So that's the first rule we applied. We basically distributed. And then what we can do is we can take out a scalar. We could take out these scalars here, this 3 and 2. So what that means is, let's say you're taking the cross product between, let's say, Ka and let's just call it vector B by itself. This K is a scalar. Well, basically what you can do is you could keep the scalar on the outside and then just take the cross product between A and B. So just kind of keep it on the outside and then just do the cross product between those, and then whatever that is multiplied by the scalar. So we can do that here. We could take the 3 and the 2, we could put in front, so that would be a 6, and then we'd have B times A. Then this 2, let's put in front, so we got minus 2, and then we got C times A. All right, so getting a lot closer, notice that we have expressions for A times B here and A times C, but notice here that we have B times A and C times A. And here is one of the trickier parts of this question. If you remember cross product rules, if you have A times B and you want to switch the order, then you would have to put a negative in front. The whole thing would have to be multiplied by -1. Right? So if you switch the order, you got to switch the sign as well. So notice that we have B times A here, but that's not the same as A times B. But we could switch it to be A times B, but then we have to put a negative in front. So this would be like -6 A times B. We just put that negative in front of the 6. So we're applying this rule over here, right? When you switch the order for a cross product, the sign is changing. Same thing here. We got C times A, but here we got A times C. So we want to switch this into A times C. So we're going to have to put a negative there, and then negative and negative make it a positive. Right? So we're just basically switching that sign. Right, so pretty much everything stayed the same. We just switched the order, and then we switched the sign. This +6 turned into a -6. This -2 turned into a +2. And now notice that we can input for A times B this vector here in component form. So 3, -2, and 5. So 3, -2, and 5. And then we got +2. And then A times C is 9, 7, and negative 2. And then what is that going to equal? So we would take negative 6 multiplied by 3, which is negative 18, plus 2 times 9, which is 18. So negative 18 plus 18, that gives us 0 for the x component. Negative 6 times negative 2, positive 12, plus 14 would give us 26. Then negative 6 times 5 is negative 30. 2 times negative 2 is negative 4. So negative 30 plus negative 4 gives us negative 34. And that there is your final answer. You could rewrite it in component form like that. Right? So this here is this expression, 3b minus c, cross product between that vector and 2a. So actually I'll write it up here. Right? So that is your final answer. So you just have to apply these cross product rules. And the trickiest one, in my opinion, is when you switch the order b times a to a times b, you got to put a negative in front. Right? Same thing here. C times a goes to a times c, put a negative in front, then that negative and this negative turned into a positive. So that's probably the trickiest rule to see. So a lot of times here, students will think that b times a is the same as a times b, and they'll just plug this in right away, or they'll plug in this right away, not knowing that they got to switch it first and switch the signs. Right? Anyway, that is your final